Okay, let's give you guys some more practice. So the equation for the red line here, the equation for this red line here is given by this. Ignore this negative side. Okay. So and the equation for the blue line here is given by this. Looking at this area here, now we've got a choice of rotating it along the x equals -1 axis. So we're going to rotate it like this, and like this, and so on. We have a choice of rotating it 360 along the x equals -1 axis, or we can rotate it along the y equals -1 axis. The question is, which one will give me a bigger volume? Me rotating it along the x -1 axis, or me rotating it along the y equals -1 axis. So it's gonna well, which one would give a bigger volume? Rotating along the x -1 or rotating it along the y equals -1? Okay, so press pause and well, you might have a gut feeling of the right answer, but work out the volume for rotating it along the x -1, and also work out the volume for y equals -1. Okay, so press pause and have a go. Okay, so let's just look at in this case first. Let's rotate it along here first. So we've got a choice. We can either use this we can either sum up all the cylinders. So we can sum up all the cylinders. So if you look at this one particular cylinder here, rotate it around here, and then rotate it around here. The height of this cylinder is quite easy to do. It's just simply getting the the red line, take away the blue line. So you can do 2 pi and 2 pi, whatever this distance may be. That will then give you the circumference, and then you times the height. But the thing is, you could do that, but then when you're in this realm here, you've got to get this bit. To get this cylinder here, you've got to work out this height. Well, working out this height in this case is quite complicated. It's quite hard. So rather than using the cylinder method, let's sum up all the washers. So we're going to do it this way. Okay, it will be a lot easier. So we're going to sum up all the washers. So let's just look at one particular washer here. So this bit here, you're going to rotate it all the way around here, and then this bit here, rotate it all the way around here. So you're interested in this area here. Okay, so hang on. So the thickness associated with this one particular washer, well, don't forget we are moving along the y direction. So the thickness associated with this washer here will be dy. Okay, so your integral will be something dy, and then we're integrating it from 0 all the way to 2. Okay, because yeah, we're integrating it from 0 to 2. And we need the area of this big circle. So the area of the big circle would be the area of the big circle would be pi r squared. But the radius, so we need to know the radius of the big circle. We need to know the radius of the big circle. Well, the radius of the big circle would be, hang on, don't forget, the radius of the big circle would be from here all the way to the blue line. So we need a y. Don't forget, it is y that's moving along here. It is y as we are moving along, as y is changing, right at this precise point here, right at this y value here. Right at this y value here. This distance here will be given by y squared over 2. Okay, so don't forget, we are doing it this way. So y is always changing, y is moving about, but right at this precise point here, the x distance the x distance across here is given by this. Okay, and then don't forget we need to add the distance of 1 to so we've got a big circle here. So the area of a big circle will be pi r squared, but the r in this case would be 1 plus this thing here. So the radius of the big circle would be given by this. The radius of the big circle would be given by 1 plus this thing here. Okay, so hang on. So this thing here. So hang on. So we are summing up all the washers. We are moving along here. At this particular point here, this distance here is given by hang on. This distance here is given by this. Okay, and then the one here is given by, well, that one there represents this distance here. Okay, so now adding the two together would give you the radius of the big circle. So it would be pi r squared. This is for the big circle, and then we've got to take away the small circle. Well, the small circle will be pi r squared, but this r here, the radius of the small circle, is actually given by this, because, hang on, the radius of the small circle, so hang on, so we've got a big circle here, okay, and then now we need to take away the area of the small circle. Now the radius of the small circle is well, don't forget it is y that's moving about. If you want to know this distance here, it would be this thing here over 4. Okay, it would be this thing here over 4, and then, well, the radius here is given by this. Okay, it would be given by this 1 plus this. But in this region here, now in this region here, in the negative region, this whole thing here would be negative. So it does kind of make sense. 1 plus a negative number. Well, this here is the radius of the small circle. You might have to press pause and think about it. But the radius of the small circle is given by this. The radius of the big circle is given by this. I will continue in the next video. Okay.